Welcome to Spring LIB.
Okay, so we're doing chapter 35, problem 17. So we have 605 nanometer light passing through a pair of slits, which creates an interference pattern 2 meters behind the slits. And it tells us the slits are separated by a small d of 0.12 millimeters, and each slit is 0.04 millimeters wide. It says how many constructive interference fringes are formed on the screen. Okay, so first of all, we need to count the fringes that are created from the double slit pattern, which I'm going to call MD for how many fringes are from the double slit pattern. And this won't be everything, though. That's the key. So first of all, there's going to be 2 MD on either side of the maximum. So we can go ahead and count 2 of those. But there's also single slit diffraction going on from the slits themselves. And there's going to be some number of them that correspond with these constructive interference fringes from the double slit, and they're going to cancel each other out. So if we count some number of single slit diffractions are going to cancel out with these so that the M total is lower. And again, since there's 2 on either side of the theta equals 0, we have to subtract 2 times this number. So what we're trying to find is this MT, the total number of constructive fringes at the end, but we need to find MD and MS separately. So to find MD, we should know that there's going to be D sine theta is in lambda. And if we're trying to figure out every single fringe there is, what we need to do is set theta to 90 degrees, because that's the very maximum it can be. So if we do that, we have M here is given by D over lambda sine theta. So our MD is now D over lambda sine of 90 degrees, or 0.12 times 10 to the negative 3 meters over 605, that's 6 I promise, times 10 to the negative 9 meters times sine of 90. And what this equals is 198. Okay? So, another key is this does not count the 0th fringe, the one on 0, so we need to add 1 to this, to our MT. Okay, so now that we know MD, we need to find MS. So for the single slit, this is how many of these correspond with the M from the other guy. So that means we need to figure this out. We need to relate two equations. For the single slit diffraction, we're going to have sine theta equals M prime lambda over big D, the slit of the width, or slit width. And we can set this equal to the other diffraction to see how many of these are going to correspond with each other. So this is also equal to the same sine theta as before, so that's m theta over little d, or m lambda over little d. So these lambdas are going to cancel out, and we're going to see that m equals, sorry, this is md, and m prime is what we're going to call ms. So m is going to equal ms times little d over big D. And if you see little d over big D is 3, so this becomes 3 ms. Okay? So if ms is md over 3, we can see that mt now becomes 2 md minus 2/3 md plus 1. Or this is 6/3 minus 2/3, so 4/3 MD plus 1. Well, MD is 198. If we plug that in, we get an MT of 265. That's how many fringes there are. Okay,